Okay, we've looked at how to graph an equation using standard form, and we've looked at how to graph an equation given vertex form, and most people tend to find graphing from vertex form easier because it's easier to find the vertex, and that's kind of a crucial point for all parabolas. So if you're asked to change from standard form to vertex form, we have to revisit how to complete the square. Complete the square. Now, algebraically, that means get your coefficient, and this example has a coefficient of 1, which is nice. So once you make your equation have a leading coefficient of 1, then we can go to the next step, which is to, you don't have to write this down, but you have to identify your b value, which in this case is -6, right? A, B, C. Identify your b value as -6. Cut it in half, and you get -3. Square that value, and you get -3 all squared. And I'm going to leave it like that instead of simplifying it to 9. And I'll talk about why in a second. So this is the kind of thing you have to either do on paper or in your head. But working with the b value is sort of how we get to a point where we're completing the square. So y is equal to, if you remember from how to solve using completing the square, hopefully this is familiar. I need to go x squared minus 6x, and I'm going to take my plus 11 and just kind of park it over here for a moment. Now remember, if I'm going to add anything into this equation, I have to do one of two things. I either have to add it to both sides, or I have to add it and subtract it from the same side. So what I'm going to do here is I'm going to actually add this value, so -3 squared. But because I've added it in order to stay balanced, I have to subtract it back off. Now, next step, these three things. So the reason I actually do this whole b over 2 squared thing in the first place, sorry, that should be a squared. The reason I do this whole b over 2 squared thing in the first place is because I want to be able to factor a perfect square. So x minus, I don't know, something, or x plus something all squared. I want to be able to take this trinomial or make a trinomial that factors into a perfect square or a binomial square. So if I don't have the numbers I need, I make them myself. So here we go. These three things, if you were to factor them on your own, you would get x, and then this is the reason I leave it as a -3. That it tells me immediately what I have to put here. So this becomes x -3 all squared. And just to prove it to you, x squared minus 6x. Now I'll put this as a plus 9. If I were to factor this, the product would be 9, the sum would be -6. So the two numbers that make that work would be -3 and -3. That factors into x minus 3 times x minus 3. And if you want to re-expand that to check, you can. And anything times itself is the thing squared. So these three things will factor into a perfect square, or a perfect binomial square. However, I still have to deal with these other two bits. So this one, now I will turn it into a 9 and a plus 11. And I'm left with, when I simplify that and all said and done, -9 plus 11 is plus 2. And there we go. I've gone from standard form, or expanded form, into vertex form. Just so happens that my a value is a 1, my p value is a +3, and my q value is a +2. Done. So you got to be aware of how to complete the square. If you have difficulty with completing the square, then going from standard form to vertex form might prove challenging. So practicing how to the machinery of completing the square is critical. Okay, so now let's look at one that's a little more difficult because it doesn't have a leading coefficient of 1. Now, just like in the previous example, I only really cared about the a term, or the ax squared term, and the linear term, the bx term. I only cared about those two. I didn't really care about the c until later. And I'm going to do the same thing here. So for now, I'm only going to care about these two terms, and I'm going to worry about this one later. Now, some of you might say, well, why? The reason for that is that if I'm going to complete the square, remember, I need to have a third term here. So I have something x squared, something x, and then something, so that I can turn it into something that looks like a binomial square. And so I don't really care about dealing with the -1 at this time. Now, in vertex form, the lead coefficient in our vertex form, the lead coefficient of the x inside this bracket is a 1. Here I don't have that case. So with these two terms only, I'm actually just going to create, or common factor, create this so that it has a lead coefficient of 1. Okay? Haven't done, if you want to re-expand, like distribute here and distribute here, you'll get the same thing back. So all I've done is factor out a common factor so that this lead coefficient is 1. And now I can go into my technique, or my little b squared, b over 2 squared trick. Now I can go into it. So 3, and now I'm going to have a nice big bracket so I have lots of space to work. And I've got x squared minus 2x. And remember, the b value here is -2. Half of that is -1, and so I'm going to add -1 squared, but I also need to subtract it back off. Okay, and same deal again as before. These 3 bits here, these 3 terms, they will factor into a binomial square with x minus 1 all squared. Okay, but I still have this thing tacked on here, and now I'm going to simplify it to be -1 squared is just 1. Okay, these look very, very close, right? This form that I have right now and vertex form. They're very, very close, but they're not the same. And the reason for that is that I need to have an x minus 1 or x minus p squared, but I don't have a q. I've got it looks like I've got 2 q values here, so I need to simplify this somehow. And one of the easiest ways to do it is to, once I've got this, just distribute this 3 back in. Now, here I factored it out. I did some stuff in the middle, and now I'm going to reintroduce it and expand it back in. So now I've got 3 times this whole thing, so x minus 1 squared, and then minus 3 times the -1, and I get a -3. And I still have that -1 tacked on the end. And so now, -3 minus 1 is -4. I'm in vertex form. All right, that's how you do it with a leading coefficient of 1 and not leading coefficient of 1. There you go.